So yeah, we're talking about Teleporter and Avalanche Warp Messaging as well, which was uh, released yesterday with the Durango Network upgrade. And so we have two awesome special guests here from the Avalabs team that we're going to bring up. And so why don't we let them do some quick intros and for those of you that haven't met them and what you kind of do on the team, and then we'll jump into the discussion. And we'll also open it up for Q&A for the audience at the end, because I know there's probably a lot of great questions about Teleporter, how it works, how folks can build on it, how it can be implemented. So we'll get into that at the end. So excited to welcome them here. So Michelle, let's start off with you. Why don't you say hello and talk a little bit about your role?
Yeah, hi everyone. Super excited that you all are here and to chat more about Teleporter and AWM. But yeah, I'm Michelle. I am the product manager leading our interoperability efforts at Avalabs. And I've been building on Avalanche for about 2 years now. And I work really closely with Michael, who is my counterpart on the engineering side. So I will hand it over to him.
Yep. Hey everyone, excited to be here. Excited that Teleporter's on mainnet. And I'm Michael. I'm the engineering manager of the interoperability team. We originally worked on the Avalanche Bridge. Now we also work on all things interoperability within Avalanche, so subnet to subnet. And obviously that's a large reason why we're here talking about Teleporter today.
Yeah, it's really great to have you two on, because I think you both come from the same team and building the same products, but from different perspectives and angles as to how these products can be built upon and what their use cases are in the world and some of the technical details of building this. So let's jump in. And I know a lot of folks probably saw kind of the high level release of Teleporter yesterday with Durango. But Michelle, I wanted to start with you, kind of from your perspective, the high level overview of Avalanche Warp Messaging and Teleporter and kind of what this can unlock.
Yeah, absolutely. Um, some of the more technical folks have to bear with me for this analogy, but I like to give this simple train analogy to kind of explain Avalanche Warp Messaging from Teleporter and all of that. So maybe let's just start there. So yeah, think about like a train system, right? You have the train tracks or the rails, and then you have the cars, the train cars, and then you have the cargo or whatever you're trying to ship within the train. So that's kind of the system. I like to think of AWM, Avalanche Warp Messaging, also known as Warp, as the train tracks or the rails itself. It's that low level primitive, that first kind of initial level, and that is the interoperability cornerstone within Avalanche. And it's VM agnostic, and it ensures decentralized messaging because there's no additional trust assumptions. And how we do that is we have this shared P chain state that all validators know of each other's existence and who validates which subnet. And then on top of that, you have Teleporter. Teleporter is an EVM compatible cross subnet communication protocol, and it's built on top of Avalanche Warp Messaging. And what's really cool about Teleporter is that it has this really easy interface. It's implemented as a smart contract. So if you're a Solidity engineer, it should be super easy for you, right, to build a smart contract on top of Teleporter, which is kind of how you get to the cargo or the contents inside of a train, which is, think about as a generic cross messaging. Like you can literally have anything in this message. It could be ERC20 tokens that you want to transport, NFTs, Oracle price feed information, VRF data, like anything you want. And that's kind of like the highest level, which is where all of you will come in building these really cool cross-chain applications like an ERC20 token bridge or whatnot. So that's kind of how I think about all three of it together, in this like nice little package. So hopefully that helps as like a little overview.
Yeah, that's super helpful. And I think that's only the second time I've heard your train analogy, and this got much more clear this time. So I appreciate you laying that out, because I think there's a lot of folks that may not have the technical awareness of how each of these things tie together, but I think that gives a really clear picture of kind of the vision for what these different protocols and layers can do.
Yeah, and I think one thing I didn't touch upon that maybe I should dive a little bit more into is that second layer, right, which is teleporter piece, the train cars itself, like what is so great about teleporter, it facilitates these seamless connections within the Avalanche ecosystem by providing some additional mechanisms and properties that AWM does not provide by default. So Michael can definitely talk a lot more about this, but some examples of this is we also have this relayer now that is really great, and you can either run your own relayer and it's totally permissionless, or eventually with AvaCloud, that's our like blockchain infrastructure as a service type of arm. You can have AvaCloud run a relayer for you, and you just pay a very small fee per month or per year. And Teleporter also has things like replay protection, so prevents messages from being delivered multiple times, and things like message retries. So in the event that your message is dropped for whatever reason, it can get retried. So there's like a lot of things that AWM doesn't necessarily include by default because it's much more low level. And so I think Teleporter makes it much more usable. And it should be very easy for you to just kind of check it out. Everything's open source, out of the box, easy to work with.
Yeah, that's really great. I think some of those are kind of some newer concepts of things that are related to Avalanche Warp Messaging. So I think that helps a lot. But I want to kick it over to Michael. So, we got the analogy version of Teleporter. And so kind of from the more technical side, if you want to give us kind of an overview of Teleporter and kind of how it works, how it connects into Avalanche Warp Messaging, and maybe how it was unlocked with the Durango upgrade too.
Yeah, for sure. So I think the easiest way to kind of go about this and conceptualize it is to think of the end-to-end flow of sending a message between two subnets. So it starts with a transaction that's sent on the source chain. Let's just go with a theoretical example of bridging AVAX from the C chain into your subnet. So the source chain would be the C chain, and you would send a transaction on the C chain that locks your AVAX in some smart contract, which then sends a message via warp. And the key aspect here is that it's just like any other transaction on the source chain. It should get accepted and finalized just as quickly as any other transaction would on the C chain, with the side effect of once it is accepted, all of the validators, when they accept that block, they become willing to sign the message contained within it. And once that occurs, the cross-chain relaying that Michelle was talking about then comes into play. And what occurs during relaying is really just a two-step process, I would say. The first part is aggregating a signature of the source chain validators for that message, which they are willing to provide once they accept that block, and then putting it in a transaction to be sent to the destination chain. That transaction on the destination chain, again, is just like any other transaction, but the verification of that transaction verifies that the BLS signature that it contains actually represents sufficient stake weight of the source chain validator set. So it's end-to-end verification between these two subnets for that communication. There's no trusted intermediaries. As far as Teleporter and Warp, Teleporter, as Michelle was saying, is built on top of Warp and uses the Warp precompile, which was added in the Durango update. So that's why Teleporter was a very fast follow on the Durango activation yesterday. It depends on this ability within the EVM to, one, indicate to nodes that they should be willing to sign these messages using their BLS keys, and then two, also provides a EVM interface via this Warp precompile for verifying the aggregate signature from the source chain when a message is received. So those are the two calls to the Warp precompile that are made, and then Teleporter handles everything else at the smart contract level as far as the message format and the interpretation of that.
Nice, got it. Cool. Yeah, I just sorry, cut out a second there. What I wanted to. Oh,
Can you hear me?
Yeah, I think you just dropped back in. So
sorry, I think my phone locked.
It happens to me all the time. I feel you. Yeah, keep going if you had anything that you were going to finish up on.
I was just going to say the one aspect of it that makes it very cost effective and scalable is that it's just two transactions, one on the source chain, one on the destination chain, which should really only limit the latency to the block confirmation times on those respective chains, and the fact that there's no writing occurring to any global state makes it such that the number of messages in between two subnets, or that traffic levels between two subnets, have no impact on verification or sending of messages between other subnets. The verification of each message is done by reading the state of the P chain, but not writing. And that read is really just a local lookup on every node, which is essentially free. So the model lends itself to be very scalable and cost effective in that aspect.
Yeah, that's actually a good point. I was going to touch on that a little bit because we've seen some questions around what could be the cost implications of the transactions themselves, or even just like load congestion, or does it affect any other, or is it affected by any other load congestion that might be happening on maybe one of the subnets or the C chain itself? I know that might be something to help clear up for folks too. Is just like, how does this also help with avoiding any other kind of big congestion moments on any of the other chains?
Yeah, for sure. So it doesn't avoid them on a single chain. I guess that's important to call out, that if transaction fees are super high on one super popular subnet, then you will have to pay those transaction fees to interact on that subnet, including interact with it via a teleporter. However, teleporter fits in very well with this subnet architecture, in the sense that if there's a lot of congestion on one chain, it does not impact other chains. And that's the case with Warp and cross-chain messaging, because of that reason that I was alluding to earlier, with the fact that verifying a message is only dependent on reading the current state of the P chain, which all nodes currently validate, or all subnet validators currently validate. And that results in it being just a local lookup, which is essentially free and doesn't have any impact on any other chains. So as long as each chain is ticking along itself, it should be just fine.
Awesome. Yeah, that's good. Thanks for the clarification. And kind of just building off of that. So one of the things that we've talked to a lot of folks about is, okay, the capability is now live. Warp precompile, and now you can build on teleporter. And so now I would imagine there's builders that might already be in the process of thinking about creating a subnet, or they've already built a subnet, or looking into just the possibilities here. Where is the best place for them to kind of get started? And what are some other kind of key technical components of teleporter that maybe developers should be aware of for how they're looking to integrate this into their own subnet?
Yeah, I would break it down into two main categories as far as the technical components of teleporter. One are the teleporter contracts, or the on-chain components, and then the second one is the off-chain component, which is the AWM relayer. So I can dive in a bit more into each of those. So the teleporter contracts, well, both of these are open source on GitHub, and you can find them in our repos. The teleporter contracts can be deployed by anyone to their subnets now that Durango is active. So the teleporter contracts depend on the Warp precompile being present, but that was added as a part of the Durango activation, like I said. And anyone can deploy this, and it actually occurs by deploying it to the same contract address on every chain using this super cool technique called the Nix method for keyless transactions. If you're interested in that, we link to some resources within the repo, and I'm happy to talk about it with anyone more, but it's definitely very technical and low level, so I'll skip that for now. But higher level, anyone can deploy these smart contracts to their chains. There's the teleporter messenger contract, which ends up at the same address on every chain, and the teleporter registry contract, which anyone can deploy, does not need to be at the same address, and it allows application developers to easily and seamlessly, really automatically get any new teleporter versions that are deployed and leverage those. So if there's ever a new version of teleporter that we deploy on the C chain and anyone can deploy on their subnets, applications that leverage this registry will automatically point to the new version. And then for the off-chain component, the AWM relayer, that stood up just as you would stand up any other node. It does need to be provided with funds to be able to send transactions on the destination chain. But again, it's fully permissionless. Anyone can
Sounds like we might have lost you again. Might have got that phone lock on.
Oh, my bad. Yeah, we're in the process of making that relayer deployment as easy as possible.
Awesome. Yeah, and while we're talking too, I'll see if there's any other tweet links that I can pop up here that might point people in the right direction. But we've got like really, I think, a good technical overview of kind of how all these pieces fit together. And I think what I'd also love to hear about is kind of, okay, what's next? What's coming in the future? And I think a lot of that can be talked through in the perspective of use cases, right? And Michelle, I want to kind of kick it back over to you, is like, as you're talking to teams that are building, or as you're kind of talking to potential founders and stuff, like, what are some use cases that kind of bring teleporter to light, that can kind of show people what's possible that maybe not have been possible before?
Yeah, absolutely. Maybe just before that, I wanted to tag on to what Michael was saying about what devs can look into or better understand, or provide feedback on Teleporter. Is, yes, there's those two repositories, but there's also this really amazing Ava Academy course that our DevRel team worked on. So it's totally free and it's an amazing course. Highly recommend checking it out. We also have some docs up as well. If you find that anything's difficult to understand or some context is missing, we would love feedback. And then also right now, we do have ohmywarp.com. So if you just go over to that website and check it out, you can actually mint these mock tokens on C-Chain and then bridge it over to these testnet subnets called Dispatch and Echo. So highly recommend checking that out. And I also have a few explainer tweets on my page as well, and Michael has some really great ones as well. So there's a lot of information out there. But yeah, so use cases, right? So the use cases are truly endless. Like, that might sound corny, but it really is. And I get so excited thinking about it because, it's generic message passing. You can literally send whatever your heart desires. So maybe just first a little background in terms of how I'm thinking about the world right now is, we're in a really interesting phase where technology is developing rapidly. You have incredible innovations across the board in AI, blockchain, and so many other spaces. And there's an abundance of knowledge of people and of things, and we're more connected than ever. And we're connected digitally. And so ownership is really important in this era of abundance, right? So when you think about use cases and examples, I like to think of different verticals. So let's first start with these enterprises or financial institutions. Some of these institutions want to do something like, create a subnet, but they don't want Ether or AVAX as their native gas token because, the prices, as we all know, can fluctuate quite a bit. So maybe they want something more stable like USDC or another stable coin. So what Teleporter and Warp enable is that anyone can basically take native USDC from C-Chain, bridge it over to their subnet, and use it as a native gas token of that subnet. Like, that is a really, really awesome use case for financial institutions and enterprises. Another example, think about gaming. Let's say, or yeah, Kyle, you had actually posted about this, which is, I think it was like creating gaming environments where one subnet can unlock like features on another subnet. So let's say you're an avid gamer and you spend something like 80 hours a week gaming. You're probably pretty good, or I hope you're pretty good because that's a lot of time to be spending on gaming. But yeah, let's say you spend hundreds of hours playing a game on like Gunzilla, like their subnet. And now imagine that you have NFTs that represent these skill points, or you have like skins or weapons or whatnot. Um, and you have this digital representation of all the time and hard work that you put on it. And then now let's say you want to play a different game, let's say on Shrapnel and their subnet. Well, there might be a way where you can, have some sort of partnership with Godzilla and Shrapnel where you don't have to start all over again, but you can, have a checkpoint or have some sort of boost, because you're able to bring these NFTs from the Godzilla subnet to the Shrapnel subnet and then reuse some of these skins, weapons, or, have tokens to bootstrap you to be able to buy some of these things. So with Teleporter, you can just go easily from game to game, subnet to subnet, without having to think twice about it. If you're not a gamer, the last example I'll just give is something like more retail. So think about like loyalty points and reward points. I might get a little girly here, but LVMH, right? For example, Louis Vuitton, they have 75 plus luxury brands, like Tiffany, Sephora, a bunch of different brands. If you're an average person like me, you're probably not buying like an expensive LV bag every year. It might just be like a one-time thing. But imagine if that bag helped you get some sort of loyalty point system. And then you were able to then use those points somewhere else, because, I'm not going to go and buy another LV bag. So instead, what you could do is, maybe go over to a Sephora subnet, because it's all part of LVMH's conglomerate. And you can, purchase makeup or whatever you want at Sephora for those loyalty points that you earned buying that LV bag. So these points are transferable because you can use Teleporter to essentially go from one subnet to another. Another example, just think about like going to Starbucks or Dunkin' or something, and you want to exchange these point systems. So yeah, I think there's so many cool use cases. And as Michael kind of already touched upon, is that we have these application contract examples. So we have an ERC20 token bridge, we have a native token bridge. We also have, Michael has this really cool contract that leverages Chainlink's VRF functionality that's currently available on the C chain. So you can use that and create things like simple betting games on your subnet. So yeah, there's a lot of stuff there. Hopefully that's helping you think of some fun use cases that you might be interested in building out.
Yeah, I think just to build on that a little bit, the way I think of teleporter use cases is less concrete, maybe as an engineer, but I like to kind of phrase it as teleporter enables services that are offered anywhere within Avalanche to be available everywhere within Avalanche. So previously, if you are a subnet project, you're standing up your new subnet, you need to think about all of the different integrations that you would need on that subnet to really have it reach its full potential. You might need Chainlink price feeds, you might need exchange integrations, you might need a cross-chain bridging provider to Ethereum, you might need a VRF service, all of these types of things that are really building blocks for cool applications on blockchains. Teleporter enables subnets to use those services from other subnets. So you can, get your or mint your token on the C chain and then move it into your subnet. That's the most obvious or basic use case. If there's a subnet that provides VRF functionality, you can now use Teleporter to query it for your VRF values. If there's a subnet that provides functionality to bridge to Ethereum, then you could use that subnet via Teleporter to access Ethereum in that route. So all of these services and like building blocks that are necessary to develop your really cool, interesting blockchain applications are now available to subnets as long as they're available anywhere within Avalanche. And as a starting point, fortunately, all of those services were built up over the years on the C chain already. So, ideally, they could be their own subnets in the long run, but right now, as a new subnet, you get access to all of those services via Teleporter from the C chain.
Yeah, that's super interesting. Actually, I didn't think about it that much about existing just the services that could be used and not necessarily like full application to application, but specific like use cases. And I was hearing someone else talk about like the opportunity to spin up like more social good subnets where one of them is just like a data oracle and price feed for a specific use case or VRF or something like that, where the subnet is just meant for that and other subnets can then tap into that to get that information. So I think that's another route that has endless possibilities.
Yeah, for sure. It's really a whole new kind of way of thinking about things as far as blockchain applications go. Because previously, all of those services needed to be available on a single chain for them to interact properly. But with Warp and with Teleporter, that's no longer the case. So you could have chains dedicated to specific applications and specific services offered to other chains. Exactly as you said. Yeah, so it's a whole new paradigm in that sense.
Yeah. Oh man, it's exciting to see what's going to happen in the coming months and coming years to see where the experimentation takes that. And that kind of leads into some of the things we kind of wanted to wrap up on. And Michael, you probably can answer this, but Michelle chime in as well. Is like, how does Teleporter and the capabilities that it opens up kind of align with the longer term vision of the Avalanche network, right? Like the idea of becoming this like hub or launch pad for any type of emerging blockchain application and application specific chains as well. And this idea of like homegrown asset value, like how does Teleporter kind of fit into that vision?
Yeah, I think a large part of it is what we were talking about as far as it enables new chains to have instant access to services anywhere else within Avalanche. And that's a huge benefit for projects looking to launch their own subnet. And also then enables kind of those you get some type of network effect as far as once all those services are available, the new subnets that are created and leverage them will be more interesting, and that just results in more services being developed to help provide more interesting subnets, and you get that flywheel effect going. And Teleporter, I think, is a real building block to making that possible. Yeah, and I'm super excited to see all of the possible use cases that come about from it. I think one thing that we're really kind of anxious but also excited at the same time to see is what people will build with it. Because of course we're not building this to build the applications ourselves. We're building this to provide the primitive for others to have the best platform to build on top. And so any feedback that you have on how we could make that easier or what changes we could make to allow people to build even more robust applications, we're all ears, and that's what we're hoping to do.
Yeah, it's just a starting point.
Yeah, and I'll just add, Teleporter really makes native interoperability so easy, right? Like, I love the way that Michael put it, which is it really enables services that are offered within Avalanche, especially the C chain. There's already so much stuff that we have there. So, like, whatever's on the C chain, all these services are available now everywhere on Avalanche, on all the other subnets. So I think that is one of the huge value props, right? It's this interconnectedness. And I think this has been something that's been missing for a long time, but we really, since inception, have been thinking and trying to build towards this point in time. So super, super excited to have this ready to share with everyone and super excited to see what you all build. And the last thing is, we've kind of made it really easy for this native interoperability. So now the builders and the applications can actually focus on building out user intents, things like meta transactions and helping, getting dApps to build out gas abstraction or gasless experience for users that will really drive that next wave of massive adoption. So yeah, we hope that you'll join us on this path to 100,000 subnets.
Yeah, it's a great way to put it. Yeah, and we're going to be, doing our best to share over the coming months and years all the great like new ways that people have thought of using this technology and implementing it to create more synergy and cohesion across the network. So there's probably a lot of things we haven't even thought of yet that we're going to be sharing and talking about. So it's exciting to see. Yeah, Michael, I'm going to let you chime in 1 sec. But in the meantime, if anybody has any questions, call up to hit the mic button, be a speaker. And so, Michael, while you're finishing up, I'll just see if there's anybody that we need to add up to the stage here.
Perfect. Yeah, I just wanted to add that, I think one other way that teleporter really aligns well with that long-term vision of Avalanche as far as serving emerging blockchain applications is the flexibility it has to interact with more virtual machines in the future. That's another big effort of ours with the HyperSDK. And as those technologies get put into place, we hope to be able to integrate teleporter with them. So this isn't just EVM to EVM. It is for now, maybe, but it's definitely designed with future VMs in mind.
Yeah, absolutely. Man, it's awesome. We're going to jump into some Q&A. If anybody has any questions, someone add people up as we go. Of course, as a reminder, we want to just honor our guest time here and focus primarily on Teleporter and Avalanche Warp Messaging. Any questions you have around this technology? We have other spaces where there's lots of other things that get discussed across all the different things happening on Avalanche. We want to keep our discussion here focused on Teleporter. So let's call up some questions and then we'll go from there. So Crypto Kinder, you're up first. How you doing, man?
Good, man. How you guys doing? Exciting stuff. Glad to hear it. It's finally here. A bit over my head, so if this question doesn't make sense, I apologize. But is there any potential for an attack vector from a completely compromised validator set, since it all goes through the P chain, and the assumption is that the P chain state is correct? Is there any attack vector for a totally compromised validator set to create a false state and use that to try and withdraw resources from other chains?
Yeah, I can take this one. It's a great question. Definitely something that we had in mind when building it out. The answer is that it should be as secure as the chains that it is connecting. Which isn't to necessarily say that it will be secure, right? Exactly as you pointed out, like if you are running your own subnet with a single validator on your home laptop that you are clicking a bunch of random links on, then it's probably not a secure subnet. If the keys for that validator are compromised, then attackers would be able to forge your validator's signatures. But similarly, that's the case without Warp, right? So if all of the validators of a blockchain are compromised, then that chain is compromised, and that is kind of the foundation that we're building upon. Is we should be as secure as the validator sets of the given chains are connecting. I think that's also a big opportunity to tout more decentralized subnets, and we have elastic subnets that are possible to build out, and also for best security practices as far as how you store your validators keys and whatnot. Definitely a very interesting discussion area that we could go into for sure.
Yeah, I would just add to that is, it's really up to the recipient subnet or the destination subnet to do what they want with that message, right? So there can be a lot more checks on the subnet level to, make sure that, hey, if you get a message, it's like, send me 1 million tokens, that you don't actually execute that.
Awesome. Thanks. I hope that is that anything else you wanted to add to that, or does that help kind of clarify things?
Yeah, it does actually. I guess the only follow up then would be is for smaller subnets. I imagine then it might be harder for them to build those relationships with, or getting the permission to. I had a call jump in there. getting, the ability to call from other subnets if they don't necessarily like the security of them. So, what's a good way for the smaller networks to build up that trust with other subnets in the ecosystem?
Yeah, so I think the interesting aspect here is that a compromised validator set only affects that individual subnet, including anything that subnet controls on other chains. But let's take a bridge, for example. Say you created a bridge from the C chain to your own subnet. That's insecure. You run it a single validator on your laptop. If your validator gets compromised, or rather taking a step back, assuming everything's happy, your messages are flowing in both directions, the C chain is willing to validate that the messages from your subnet were actually signed by your validator, and that's permissionless in that sense. So there's you don't need to build up any reputation there. It's all just whatever your current validator set is. Your validator isn't able to take or access more tokens than have been bridged from the C chain into your subnet. So if you bridge $10 into your subnet and your subnet gets compromised, if your subnet validator gets compromised, rather, then the attacker could theoretically take those $10 on the C chain, but it can't compromise anything else on the C chain. So similarly, if a subnet's validator set is completely compromised, then you could also affect the bridge applications into that subnet, but that doesn't affect the other chains outside of the specific interactions for that given subnet.
Got it. I think that answers my question a lot better. Thank you guys. And again, super excited. I think we've all been waiting for this day for a long time. So it's great to see you here.
Yeah, likewise. Thanks for being here.
Yeah, appreciate you coming up.
Excited we got to this point for sure. It's been a long time coming.
Yeah, we were on the dev community call earlier, and yeah, I think Steven brought up that the first Avalanche Warp message was sent December 2022. So we've been working on this for a long time. I'm glad to see it kind of finally come to light. All right, it looks like I guess last chance if anybody else has a question for the team here, kind of at any level of understanding of Teleporter and its technology. So we'll give 1 sec for anybody else to call up and request. But in the meantime, any final thoughts on things people should look out for or ways people could learn more about Teleporter? I have some stuff here dropped at the top where you can see the tweets about Oh My Warp, where you can kind of see it in action. The developer docs, the GitHub repos, the Teleporter Avalanche Academy course, all that's here at the top for people to dive into. But Michael or Michelle, anything that you want to share for final thoughts on kind of what we can look forward to in the next couple months?
Yeah, I think the last thing is, please do try to provide feedback if you have any. All the repos are open, so you can create a discussion or GitHub issue or something like that if you ever have questions. We really do want more community involvement, and also, ideally, if you have a question and you put it in a public space, someone else probably has the same question, and so it's going to get answered and more people can see it. So I think that's a really great way to learn. Yeah, I think that's pretty much it.
The note that I would end on is something that Michelle touched upon earlier as far as the Ava Academy Teleporter course. I think it is far and away the best entry point if you are, confused about what we're talking about, or don't want to jump straight into Solidity smart contracts or whatnot. It does a great job of breaking this all down and visualizing it and taking it step by step. So would really tout that. And I guess would just end by saying, yeah, we're really viewing this as getting across the starting line, not getting across the finish line with the launch yesterday. So we're super excited for everything that comes next.
Awesome. Yeah. Okay. Well, that makes a lot of sense. I think there's so much to come. This is just the starting point, and there's lots of resources to dive into. So we'll wrap things up here. Michael, Michelle, thank you so much for joining us and breaking this all down. I know you both have had a busy week and a busy few months, but I think this is a great way to reintroduce Teleporter and to just, create vision for what can happen next. So I appreciate you both coming on, and everybody else that's been listening in. We'll drop this recording up on YouTube here in the next couple of days. But yeah, thanks everybody for joining, and looking forward to what's coming next.
Thanks, everyone, and thanks for organizing this, Kyle.
Yeah.
Yeah, thank you for tuning in.
All right. See ya.